Hi friends, you're back with me, Professor Girish Kukreja. Today we'll be talking about what is called as the energy charge. You feel so charged even after listening to that particular energy charge. Yes, today we'll be talking about what is called as the Atkinson's energy charge, a concept given by D.E. Atkinson long back, where we were trying to sum up that how exactly these particular nucleotides of your ATP, ADP and AMP, they are regulating the entire metabolism of the cell. We know it may be respiration, it may be the oxidative phosphorylation, it may be glycolysis, it may be any other metabolic process where these ATP and ADP are involved. We know that these nucleotides, the concentrations of these nucleotides, they play a major role in allosterically regulating these particular pathways. So which pathway is going to be turned on and which pathway is going to be turned off is going to be decided by the concentrations of these nucleotides. You must have also heard about AMP, one of the real brothers of this ATP and ADP, the smaller one probably. So this AMP also, you encountered this AMP during many biosynthetic reactions where there is a liberation of pyrophosphate from ATP. There is a formation of this particular component of the adenine nucleotide group, that is your AMP. AMP can also be again rephosphorylated to form your ADP by the enzyme adenylate kinase, right? Where this combines your ATP with your AMP to form two molecules of your ADP. It is this particular view of these metabolic reactions where this ATP, ADP and AMP, they are acting as the modulators, where D. Atkinson told that these could actually decide the energy status of the cell. He called this as what is called as the energy charge of the cell, right? And he told that was this particular poise which will what you call as decide. The poise refers to the equilibrium or the balance of these allosteric modulators which is under the control of this particular energy charge. Yes. So talking about energy charge, he told that it is something which defines this ADP, ATP and AMP, all three together. So your ATP, adenosine triphosphate, ADP and your AMP. This entire adenine nucleotide system, how much filled this particular system is, right? That is what is called as the concept of what is called as energy charge, right? You may have a situation where there are a very large number of these what you call as high energy phosphate groups. Like you can say this entire ATP, ADP and AMP system where all the nucleotides are present in the form of ATP, right? I'll say that this particular system is completely charged. So that value was given as value of 1. So we can say that a completely filled system, right, where there is maximum amount of energy in the cell is when all the adenine nucleotides are present in the form of your ATP. You can have an exactly reverse situation where all the nucleotides of adenine are present in the form of what is called as your AMP, right? In this case now we can say that the energy charge of the cell is 0. So you have a situation where everything is 0, where everything is in the form of AMP. You have a situation where we have completely filled, everything is in the form of ATP. But then we know that it is not always black and white, there are the shades of grey. So talking about halfway, midway, right, we can say that it would be half filled when all the components are in the form of your ADP. This will also be true when you can say that it is having say equimolar concentrations of your ATP and AMP. So all adenine nucleotides in the form of ADP or all adenine nucleotides in the equimolar concentrations of your ATP and AMP, both will keep the energy charge of 0.5, right? So you can actually calculate the energy charge of a particular cell by a simple formula where it says that energy charge is equal to half of your what you call as ADP plus 2 times of ATP, probably it has twice the energy of that, whole upon the concentration of all three, your ATP, ADP and AMP, right? So this gives what is called as your energy charge. So it was Atkinson who told that it is this particular energy charge which will decide that which reactions will proceed in a particular cell, right? You can see in this particular curve where there are two what you call as curve. One curve is what you call as those which are representing energy yielding what you call as reactions which generate ATP. The other curve is the curve which shows the energy utilizing reactions. You can see the biosynthetic reactions. So energy generating reactions, like you can have catabolic reactions. Energy utilizing, ATP utilizing reaction, you can have biosynthetic reactions. The point at which these particular curves, they intersect, probably that will what you call as represent the actual poise. That will represent where there is some stability, or that is representing the what you call as balanced energy charge, where everything is balanced. Your formation of ATP and your utilization of ATP is being balanced. It was actually found that the point where this intersects, it corresponds to the energy charge of 0.85, right? So we have 85% charge. So as the value, as I told, it ranges from 0 to 1. This poise, it was adjusted to around 0.85. So where these two curves meet, right, the ATP utilizing and the ATP generating, where these two curves meet, that value is around 0.85. And that was found when it was calculated in most of the normal cells, resting cells or fasting cells also. It was found that that is the actual energy charge. You go a bit away from 0.85, like say for example, if your energy charge decreases below this 0.85, you will find the reactions which are what you call as generating ATP, right? Those reactions, they will be what you call as favored, and you will find that there is an increase in the rate of those reactions which form your ATP, ADP, AMP, which act as the modulators, right? They will allosteric modulators. They will go and act in such a way that those reactions, they will be increased, and those which are actually utilizing ATP, the biosynthetic reactions, they will be decreased, so that you don't move away much from 0.85. So where you are less than 0.85, you need more ATP, and you will reduce the utilization of ATP because you are already less than the value which you had already set, right? Now, if reverse things happens, like if your energy charge is going 0.85, anything in excess is not good. Anything is less is also not good, but then excess is also not good, right? So if you go more than 0.85, you will find that again the reactions which are generating ATP, these allosteric modulators will work in such a way that those reactions which are generating ATP, they will go down. Those reactions which are utilizing ATP, they will go up, right? So again, you will come around at around 0.85, right? So very rarely, like not rarely, it is properly balanced at this particular 0.85. So the energy charge is strongly poised there. So there is a strong what you call as resistance from any deviation from this particular value of 0.85, right? This was the concept of what is called as your Atkinson, and is popularly called as the Atkinson's energy charge. So stay tuned, stay charged, and keep your poise at 0.85. Thank you so much. So if you need anything more, you may mention in the comment box that what you want to learn from us in microbiology, biotechnology or biochemistry. Stay tuned with me, Professor Girish Kukreja. Thank you.